Assalamualaikum and hello. My name is Mishahada bin Shar FND and my metric number is A25CS0331. In this video, I will demonstrate the use of Cinebench 2026 to execute workload A and workload B. I will also explain how the required computer organization and architecture performance metric are obtained and analyze the benchmark result. Cinebench Cinebench 2026 is a benchmarking application developed by Maxim. It measures computer performance using industry-standard three-dimensional rendering workloads. The tested computer used 12th Gen Intel Core 17-12650H. It has 10 processor cores and 16 logical threads, and it operates on Windows 11 64-bit. The application also detects an NVIDIA GeForce RTX 4050 laptop GPU. However, this project focuses on CPU performance, so the GPU benchmark is not used. The GPU option evaluates graphic rendering performance. CPU multiple threads uses all available processor cores and logical threads simultaneously. It is suitable for measuring parallel processing performance and total CPU throughout. CPU single core evaluates the performance of one processor core. It is useful for examining individual core execution efficiency without the full advantage of parallel processing. CPU single thread runs the benchmark using one logical execution thread. For load B in this project, CPU single core is selected according to the benchmark procedure used in the report. The MP ratio compares multiple thread performance against single core performance. A higher ratio indicates better performance, scaling when more cores and threads are used. The minimum test duration determines how long the benchmark continuously repeats. A longer duration can reveal whether CPU performance remains stable when processor temperature increases. And for minimum test duration, there's two choices, which is 10 minutes and 30 minutes. So for workload A, before executing workload A, the benchmarking environment is controlled to improve the reliability of the result. The laptop needed to connect it to AC power. Windows power mode is configured to the best performance. Just let me show you. As you can see, it's on the best performance. And an unnecessary background application are closed. This actually reduces interruption of power-saving behavior and competition for processor resources. So, workload A evaluates sustained multi-core CPU performance. First, the minimum test duration configuration to 30 minutes, which is 30 minutes, and next CPU multiple thread will be selected. And during this benchmark, all available processor core and logical thread work simultaneously to render the scene. This simulates demanding parallel workloads such as three-dimensional rendering, video encoding, engineering simulation, and scientific computing. So after the benchmark was completed, the multiple thread score is recorded. The processor obtained a workload A score of 1,787 points. The required COA performance metrics for the workload A are CPU execution time, task level throughput, and pipeline saturation efficiency. CPU execution time represents the time required to complete the benchmark workload for the same task. A shorter execution time indicates better performance. Throughput refers to the amount of rendering work completed within a given time. Therefore, a higher multiple thread score indicates greater task level throughput. Pipeline saturation efficiency refers to how efficiently the benchmark keeps the available cores and execution resources active. Since this workload uses all 10 cores and 16 logical threads, it tests the processor ability to execute parallel operations. So now, we will do workload B. For workload B, it evaluates individual processors' cores performance. And for this workload, the minimum test duration is configured to 10 minutes. CPU single core is then selected by clicking the Start button. Unlike workload A, this benchmark does not use all processor cores simultaneously. It focuses on execution capability of one processor core without the full benefit of parallel processing. So we'll do the single core for workload B. So after the benchmark is completed for workload B, the single core score is recorded. The processor obtained a workload B score of 386 points. The required metric for workload B includes single thread instruction, pipeline efficiency, and maximum boost clock behavior. The single core indicates how efficiently one processor could execute the rendering instruction. A higher score generally presents stronger individual core performance and effective instruction execution. However, Cinebench does not directly display the exact instruction per clock value. Therefore, the single core score is used as an indicator of instruction throughput, rather than being reported as direct APC.
So we can compare workload A and workload B. Workload A obtained a multi-score of 1,787 points, while workload B obtained a single core score of 386 points. Workload A used all 10 processor cores and 16 logical threads for 30 minutes. In contrast, workload B used only a single processor core for 10 minutes. These two workloads measure different aspects of processor performance. Workload A evaluates the processor's ability to execute multiple instruction streams simultaneously by using all available cores and threads. Therefore, it focuses on task-level throughput and sustained pipeline utilization. On the other hand, workload B evaluates the performance of a single execution pipeline using only one processor core. Therefore, it focuses on single-thread instruction pipeline efficiency and clock-to-clock performance. Workload A is more suitable for applications that benefit from parallel processing, such as three-dimensional rendering, simulations, and video encoding, while workload B is more relevant for applications that rely heavily on single-core performance, such as gaming, office application, and web browsing. Overall, both workloads provide a more complete evaluation of the processor because workload A measures total multi-core computational capability, while workload B measures the execution efficiency of an individual processor core.
So in conclusion, Cinebench 2026 successfully demonstrates the difference between multi-threaded and single-core CPU performance. Workload A evaluates parallel processing, task-level throughput, and utilization of multiple processor resources. Workload B evaluates the execution efficiency of an individual processor core. This benchmark demonstrates that computer performance depends not only on the number of processor cores, but also on workload characteristics, instruction execution efficiency, thermal condition, and resources management overhead. So that's it for me. Thank you.